All right, so this is similar to what we did this morning, which is the good news, okay? Except for instead of just always being y and x, there's going to be a context to the situation. So our axes won't be the y-axis and the x-axis. They'll be something called something different, depending on what the question's about. But the ideas transfer from this morning. Slope, rate of change, y-intercept, initial value, equation, okay? All right, so we know that a linear relationship has that general form. If you remember from yesterday, if b is a number other than 0, we call this a partial relationship. But if the initial value was 0, it's a direct relationship. So that all depends on the initial value. And y refers to the y-axis. But it won't always be called the y-axis if we're doing word problems, and x refers to the x-axis. But it won't always be x if we're doing word problems. Okay? So, our first question. Hayden is putting money in his savings account each week. Determine the rate of change m of the graph and interpret its meaning as a rate of change. So we know rate of change means slope. Okay, and we're given a graph, so we want to make a right triangle and get our rise and run. Okay, so I know that's a point on my graph. Great. Find another corner that you know that goes through for sure. And you can make your triangle as big or small as you want, as long as you know for sure it goes through on a corner. Okay? Then you got to get your rise and your run. So m equals rise over run, that's our rate of change. And the only difference when they ask for a rate of change, include units with your rise and run. Okay, don't just put a number, include units. So our rise, first of all, I need to take into account scale. That's what a lot of us forgot yesterday on that one question. So working upwards, we're going by tens. So 10, 20, 30, 40, 50, but I need units, so the units for the vertical axis are dollars. So my rise is actually $50. My run, see the scale here is 1 squares 0.5 or 2 squares is 1. Okay, so 1, 2, 3, 4, 5. 5 what? Weeks. So my run is 5 weeks. And then I'm going to divide. 50 divided by 5 is $10 per, because it's over, week. So that's my rate of change, $10 per week. Then my sentence, interpret its meaning. Hayden is putting money in his savings account each week. So what would the sentence be that explains the meaning of $10 per week? Easy one.
Literally just means that he's out $10 for the account each week.
Hayden puts $10 into his account each week. So just like it sounds, $10 per week. He puts $10 into the account every week. Okay? B, determine the initial value B and interpret its meaning. So we look on the graph and see if it's on a corner, and it is. So B is right here. So B is, now when we're doing initial value, we want to use units if we can. So B is 50, would you say that is? 50 what? It's on the y-axis, dollars. What would its meaning be?
He started with $50 in the account.
He started out with $50 in the account. Perfect. And then C, determine the equation that relates the account balance A to the week W. So this is the A-axis instead of the Y-axis. And this got cut off, but this is the W-axis instead of the X-axis. Okay, week, W. Okay? So when you're making up your equation, you're going to follow. I always set it up by starting off with this, and then I change everything over. So instead of the y-axis, it's the a-axis. Amount. Amount equals, M is 10 times, not x, but times the number of weeks. 10 times the number of weeks, W, plus 50 tells me the amount in the account. Okay, so that equation makes sense. 10 multiplied by the number of weeks gets you the amount you saved, plus the amount you started with is the amount in the account. Okay? Done. All right, the graph shows the relationship between the value of a car over time. Determine the slope M of the graph and interpret its meaning as a rate of change. So you see rate of change, we know we want to include units in our slope calculation. So I've given a graph, so I'm still going to do rise over run. I want to make a rate triangle. I guess I could use the whole thing, I guess. So is my slope going to be positive or negative, and why?
Negative because the slope is going down.
Right. The value of the car is decreasing over time. Does everyone see that? So it makes sense that it would have a negative rate of change or a negative slope. Okay. So we need to figure out our rise, but we know it's going to be negative. So the rise is negative. Now what's our scale? Every square represents
10,000.
10,000?
Or, sorry, 1,000.
Every square represents 2,000? Yes? So 2, 4, 6, 8, 10, 12,000. And what are they? Dollars. Okay? So our rise is negative 12,000. And then I'll sneak the dollar sign in there. And then the run, each square is worth 1. So 1, 2, 3, 4, 5, 6 years is my run. And then I'm going to divide them. So I get negative $2,000 per year. 12,000 divided by 6. So negative $2,000 per year. What does that mean? I had to write out the meaning. Vanessa.
It loses $2,000 in value.
Therefore, the car loses. There's your showing that you understand decreasing. $2,000 of value each year. Perfect. You can say decreases in value by $2,000 each year, just something to show you know what the negative means. Okay? Determine the initial value B and describe its meaning. So B equals, so you're looking on your vertical axis, there it is. B is $20,000. What does it mean in the question? What's its meaning? Okay. The car started off being worth $20,000. Nice. Okay, then we want to make a equation to determine the linear equation that relates the value of the car V to the time in years. So you want to change your axes over to V and T, fit your slope and your intercept in, following y equals mx plus b. Someone think they've got the equation? Logan? Yes. Okay, now I want to show you something. Say you looked up your answer in the back of the textbook. Mine will probably look like that. But say you looked up your answer in the back of the textbook and it looked like this. Are you still right here, even though the textbook says that? Why? You are? Why?
Because since the first number is negative and you're adding it on to the second number, you could just subtract it.
Right. Okay, so this is a negative number you're adding on to 20,000, or you can start off with the 20,000 and subtract off that number. That makes sense. What's another way of telling that you're right? Like Vanessa's way? Is there another way of telling that you're right? The number in front of the T is the same. Does everyone see that? The number in front of the T is the same, and the number that stands alone is the same. You see that? Now, why might a textbook write it like this? When something's decreasing, they think of that as that's the amount we start with, and then we're subtracting 2,000 times the number of years. Okay? Whereas when we're in a positive rate situation, we're going to take, if we go back here, this equation made sense to us because we knew 10 times the number of weeks, that's the amount of money we've saved up, plus the $50 that was there first. Okay, and this equation could also have been written like this. And still be right. Okay, I start off with $50 and then I add $10 for each week I save. Okay? Just as long as the number in front of the variable and the number that stands alone are the same. Okay? Good. So we're continuing with this one. Oh no, we're on to a new one. Great. The graph shows the relationship between the water pressure P in kilopascals and the depth D of the diver in meters. Determine the rate of change and describe its meaning. Yep. Yes, sure. Everybody, find the rate of change and describe its meaning. Oops. Okay. If I make my triangle really slow and small, it can be 50 kilopascals. It shouldn't matter how you make your triangle, you should get the same as me. Over 5 meters, which should give you 10 kilopascals per meter. How many people got 10 kilopascals per meter? So just, let's see what it says. Read the question. The graph shows the relationship between the water pressure in kilopascals and the depth of the diver. So if you get 10 kilopascals per meter, how would you describe the meaning? Is the pressure increasing or decreasing every meter? Yeah, increasing because it's a positive rate of change. So therefore, the pressure increases by by 10 kilopascals every meter. So every meter you dive down, the pressure gets more. And if you think about going down in a pool, that makes sense, right? The pressure you feel on yourself increases the farther down you dive. Okay? All right. B, determine the initial value and describe its meaning. Okay, so let's go back to our graph. Initial value is 0. Does everyone see that? There's our initial value. B equals 0 kilopascals. How would I describe its meaning? Yep.
Therefore, at 0 meters of depth, there is 0 kilopascals.
Okay, so at 0 meters of depth, the pressure is 0 kilopascals. Pressure is 0 kilopascals. That's fine. Or you could say before you dive down, the pressure is 0 kilopascals. Okay, just make sure you know that you understand what the initial value means and you're good. Okay, so now we want the equation. So make sure you use the variables that we use from the graph. You put the correct slope number in, the correct intercept number in. Yep. It follows y equals mx plus b. Oh, straight line. Look, then you can always tell because the word's line. Yep. All right, so y equals mx plus b is going to turn into what equation? Amelia? Nice. P equals 10x. How many people got that? Excellent. Okay, P equals 10x. All right. Yep.
Would it be equals 10b? Yep.
Oh, did it say D?
Yeah.
Yes, it should be. Oh, yes. Okay, so even though it didn't say it here, it did say it here. Where does it say D?
Sorry, the question.
What are we even talking about?
And the question.
Oh, here. It says this is the p-axis, and this is the d-axis. So yours is right, Amelia. Just this is a d instead of okay. Still the same equation. All right. Is this a direct variation or a partial variation? How do you know? Carter.
That's the direct variation and start at 0.
Good. Direct variation. Because I'll go back over it. The initial value is 0. So a direct variation, I don't have it up here, but I have it on the very start page here. A direct variation is a linear relationship with the initial value is 0. And a partial variation is a linear relationship where b is any number other than 0. Okay? If it goes right through at 0, it's direct. What it really means is if x doubles, y doubles. Okay, that's what direct means. Whereas if it's a partial relationship, only part of it is doubling. Okay, and then you also have an initial value. I'm just saying if x were to double, y would double with a direct variation. If you were to multiply x by 3, then y would also get multiplied by 3 if it goes through 0, 0. But it doesn't work like that for a partial. Okay, but what you need to know is that it's direct if it's a line that goes through 0, 0, and it's partial if it's a line that doesn't have an initial value of 0. Initial value is somewhere else. Okay? So if we look at this one, is this one direct or partial? Partial. Initial value is not 0. How about the car? Direct or partial? Partial. The initial value is not 0. But here, the initial value was 0, so it's direct. And let's look at our doubling thing. For Zoe. So, to get from 5 to 10, I times by 2, right, Zoe? Now look what's happening here. So to get from 5 to 10, I'm actually going from, at 5 I'm at 50, and at 10 I'm at 100. So I've also doubled my pressure. So when I double my depth, my pressure doubles, meaning it's direct. Okay, if you tried that with another one, it wouldn't work. Okay. All right, on to the next question. The relationship between the cost of a large pizza and the number of toppings is linear. Determine the rate of change and describe its meaning. Yep. Yes. Do you know how to do this one? Do you? Determine the rate of change and describe its meaning. Does that give you a hint? Yes? Okay, so there's a hint. That's how you're going to start figuring out the rate of change. What if I don't know again how to get from that? What do I do? Yep. Right. So I go 1150 minus 940 is 2.1, so 210. So up 2.1. 1360, we'll make sure it's linear even though it says it is, minus 1150, up 2.1, up 2.1, as this goes up by 1 each time. Remember when we ask for a rate of change, you need to include units. Remember in a table, your rise is the change in the second column, and your run is the change in the first column. So my rise is 2.1 what? Dollars. It says it in the chart. Nice. So I could make it $2.10. That looks prettier, right? Over, my run is 1 topping. So M is $2.10 per topping, which is pretty self-explanatory, but it still says describe its meaning. So your therefore would be it costs $2.10 for each topping. Okay, so that was the easy one to interpret. Determine the initial value and describe its meaning. So where do I find the initial value in a chart if it happens to be there and I'm really lucky? Yep. The number beside 0, very good. The number beside 0. So when there's 0 toppings, it still costs $9.40. So B is $9.40, $9.40. So what would that mean? And a no topping pizza would cost $9.40. I'm not sure whether that's just crust and tomato sauce or cheese too. Not sure. Have to ask. So there's our initial value and its meaning. What equation describes the relationship between the cost of the pizza C and the number of toppings N? So again, normally this is your X column and this is your Y column, but instead it tells us to call the number of toppings N and the cost C. Okay? So remember, X always comes before Y. So you're going to change over Y equals MX plus B into the cost is equal to, yep, $2.10 times the number of toppings plus $9.40. Okay? Is this relationship a direct variation or a partial variation, and why? Logan? No.
Partial because it starts at 9:40.
Yes. Very good. This is a partial variation because the initial value is 940. I like how Millie added on not 0. She's showing I know it is, and I know why stuff is and why it isn't. Okay? How much would 2 7-topping pizzas cost? Plan for this one? Yep.
Use the equation and insert the number of toppings.
Okay, so you can find out how much one 7-topping pizza costs using the equation and then times your answer by 2. Yep, that's how I would do it. Lovely. So you're given, here's our equation. We're finding C when we know there's 7 toppings. And then we have to times it by 2 because there's 2 pizzas. So that gives me $24.10 for one pizza. And then I want to times that by 2. So $48.20. So therefore 2 7-topping pizzas would cost $48.20. Okay, we're on the pool question. A pool is being drained at a constant rate. Determine the rate of change, the initial value, and the equation that describes the relationship between the volume of water, V, and the time, T, in hours. How long will it take until the pool is empty? Okay, I'll give you some time. Should be able to do it. So here? Okay, most people are doing the chart, so That's up to you. So I would do 31,500, take away 45,000. So I'm going down 13,500. And then I'm going to do 18,000 minus 31,500. So again, a decrease of 13,500. And then 4,500 minus 18,000, negative 13,500. And then I'm going up by 5 each time. So when I find my slope, or my rate of change they ask for, I'm going to include units. So my rise is negative 13,500. What? Then I go and look at my chart, liters. And my run is 5 west, and then I look at my chart, hours. Okay, so then I'm going to divide negative 2,700 liters per hour. So that means that every hour, 2,700 liters of water drains from the pool. The pool is being drained. So it makes sense for it to be negative, okay? Every hour, 2,700 liters drains from the pool. It didn't ask us to say that, but we can understand it. So now we need B, the initial value. Amelia?
45,000.
45,000 liters, which in our mind we know means that the pool starts off with 45,000 liters of water in it. Okay? And then we want to change over from y equals mx plus b. Instead of y, we're using volume. And instead of x, we're using time. So our equation is going to be v equals negative 2,700 T plus 45,000. So determine the rate of change, check. Initial value and equation that describes the relationship between the volume of water V and the time T in hours. And then it adds another question. How long will it take until the pool is empty? How long will it take until the pool is empty? So we know this is the equation. We know it's got two variables in it, volume and time. So they're giving you either a volume or a time in that question in disguise. So what are they giving you? How long will it take until the pool is empty? Are they giving you a volume or the time disguise? Yep.
Where the volume is 0.
Where the volume is 0. Love it. Empty means the volume is 0. So now I can put D as 0 and solve for the time. And then I will know how long it takes for the pool to be empty. By solving equations, reverse BUDMAS. I'm going to subtract 45,000 on both sides. And divide both sides by negative 2,700. And I get that the time is, two negatives make a positive, so that's a good sign. You divide them. Approximately 16.7 hours. We got 16.6666. So therefore, it takes about 16.7 hours for the pool to completely drain. So So the star to put beside this question is that you had to tell that they were giving you the clue that volume was 0, even though they didn't say it specifically. They said empty. Okay. Each table represents a linear relationship. Describe an equation that represents the linear relationship and state whether it's direct or partial. So to get the equation, you need to know M, B, and D. Okay? So you should be looking at each chart and thinking, I want to find M, and then I want to find B, and then I'll know the equation, and then I'll know whether, once I find B, I'll know whether it's direct or partial. Okay? I'll give you some time. So for the first one, I got my rate of change to be 50 cents per photo. Yes? Everybody good there? Okay, initial value, it's really easy to do common sense. So if you go back 5 here to get to 0, you go back $2.50. Agreed? Because you're always going up $2.50 every time you go up 5 photos. And that puts you at 0 as well. So initial value is $0. That means it's direct. Is everybody good on that? So because of this, we have a direct relationship. Okay, and our equation, instead of y equals mx plus b, y is being called cost, capital C, m is 0.50. X is little p, and we don't need to show the plus 0. So that would be our equation, and it's direct because the initial value is 0. Okay? Any questions about that one? How to get the rate, how to get the initial value equation, or why it's direct? Anyone? You good for that? Okay, so the second question is the same idea. So I'm going to read my boxes here. Total number of minutes used, remaining value. So 19 minus 22 is -3. But I'm going up 10. So we've got to make sense out of this negative. So I'm going to include units, -$3 for 10 minutes, which means that my rate would be -$0.30 per minute. So that means for this question, every time I use a minute, 30 cents comes off my card or whatever it is, out of my account, right? So that's my rate of change. How would I get, how would I get my initial value? How did you guys get your initial value? Yep.
I subtracted 10 from the total number of minutes and subtracted, or added 3 to the.
Awesome. Why did you add 3?
Because it's subtracting.
Subtract 3 here, so the reverse is adding 3. And then you can check and make sure that it makes sense. So 0 to 10 would be up 10, 10 to 20 is up 10, 25 to 22 is down 3, 22 to 19 is down 3. Awesome, Austin. So B is $25. So if my initial value is $25, am I direct or partial? Partial. So this makes it a partial variation. Then my equation, I'm going to switch over from y equals mx plus b. So instead of y, I'm using v value. Instead of m, I've got negative 0.30. Instead of x, I've got t for minutes used, plus my initial value, which is $25. So that would be my equation. Okay? So you start off with $25 and you subtract 30 cents every minute until you get down to nothing. Okay? All right. So our last one. Use the information to determine the equation that relates the total cost C to the number of hours N. So there is a linear relationship between the total cost of renting a costume and the number of hours it's rented. For 3 hours, the total cost is $60. For 5 hours, the total cost is $80. So when I see one like this, I like to put it into a chart. But it doesn't tell me what to put in the first column and what to put in the second column. I have to figure it out. Any suggestions? What goes in the first and what goes in the second? Yep. 8 for hours, it says N, but yes, I agree. Number of hours would go in the first one, and cost would go in the second one. What's your reasoning for that, Logan?
For 3 hours, the total cost would be.
Okay, they could have worded it costs $60 for 3 hours. If they worded it like that, would they have started with cost here? Okay, so that would trap you. Yep.
I think cost second because you only do the cost per hour.
Okay, so when you're thinking of renting something, cost per hour, cost per gallon, cost per minute, cost is always on top, which means it's in the second column. Okay? Yes. So, because they will try to trick you like that. This is an EQAO question this year. People didn't get tricked because the way they expressed it, but in other years where they wrote that out, people did get tricked. Okay? So, we've got 30 hours, and I didn't put it right near the top because I'm not sure whether 5 comes before or after it, is $60. 5 does go below 3 because it's bigger than 3, is $80. Yep.
So in this case, C would be acting as a Y, right?
Yes. So this acts as my Y, and this is like my X. So you get from 60 to 80, I go up 20. What? Dollars. Because cost is in dollars. And from 3 to 5, I go up 2 hours, because this is hours. So then I can find my slope. So we want the equation. So we need slope, initial value, equation. So $20 for 2 hours is $10 per hour. How would you figure out your initial value?
You could input, like, for example, the 3 hours is $60 into the equation we use.
Lovely. So we start with y equals mx plus b. This is going to be the x we chose that goes with that y. So we're going to replace y with 60, m with 10, x with 3 to calculate b. So we end up getting B is $30. So that's probably a deposit in case you wreck the costume or something, okay? So my equation, I'm going to change over from y equals mx plus b to cost equals 10 times the number of hours plus the $30 deposit. Is this one direct or partial? Partial, because the initial value is 30. Awesome. Okay, good job, guys. All right. And practice 21. Stop the video.